All right, number 26 on the final exam. Review. Cost of manufacturing bicycles at the production plant is given by this quadratic here. Find the number of bicycles that must be manufactured to minimize cost. Minimize. That's code for I need the minimum y value of a parabola. Okay, so that's part of the vertex. So I need the vertex formula. That is not how you spell that, but you get the idea. Vertex formula. X equals negative b over 2a. So a equals 2, b equals negative 800, c equals 92,000. Negative b would be a negative 8. 2 times 2, positive 804, and that's going to equal 200 bicycles. That is the number for that. All right, what would the cost be if you produced 200 bicycles? So the cost for 200 bicycles, put a 200 in everywhere, there is a X. And do the math. Make sure you do this first, right? This is 200 times 200, then times 2. That should come out to $12,000. Okay? All right, absolute value inequalities. This is a greater than problem. So greater thans you treat like ors, as long as this, because it's doable here. So let's see, 4x minus 6 is greater than 7, or 4x minus 6 is less than negative 7. Okay, keep one as it is. Use the word or, flip the symbol, and make it a negative or the opposite sign, okay? Let's see. So, and then solve for x. 4x is greater than 13 divided by 4 divided by 4. So x is greater than 13 over 4, or 4x is less than negative 1 divided by positive 4 is going to be x is less than negative 1/4. So think about that. Negative 1/4 is down here. 13/4 is up here. So let's see, greater than 13/4 and less than 1/4 goes down that way. And it's an or, so the way you write all that out would be, let's try a different color here. So this would be, I'm trying to picture this graph here. So negative infinity, negative 1/4, soft bracket, union, because they don't connect to each other. So this would be the minimum of this one, and then it goes to the positive infinity that way. Okay? All right, here's another absolute value inequality. We want to get the absolute value alone on one side. So we're going to move everything else. And that is a 3. No, it's not a 3. That is a 6. I'm sorry, I'm looking at my key here to make sure I did this correctly. Hang on. Negative 9, negative 9. 2, 3x minus 2 is then equal to 6 divided by 2. That's where I'm going. Okay. 3x minus 2. That's this thing. So this is going to be less than 3. That's where that came from. Okay. So it's a less than. So it's an and. So the or is a greater than. The less than is an and. Okay. I gotta hang on just a second. Let me fix my key. Alrighty. So we're going to write that twice. Remove the absolute value bars. Because it's because it's an and, we want to add a second symbol here. All right, because this was an or, we wrote it here with the greater than as it was and a less than with a negative on that side. Because this is an and, we want to put it in the middle of two symbols, just like the other ands we worked earlier, okay? And then we're going to solve for the x in the middle, putting the negative on the downside, okay? Plus 2. All right, so this is going to be x is greater than negative 1/3 and x is less than 5/3. I need a visual on that. Let's see. Negative 1/3 would be down here. Positive 5/3 would be up here. And greater than 1/3 would be this way, and less than 5/3 would be this way. So we go here like that. All right, so that means parentheses are going to face themselves. The soft brackets are going to face themselves. So that's what that's going to look like in interval notation. Okay, sorry, that's a little messy. So let's try to do another one here. This is another less than. Right here. Don't hardly see it. Let me write it back over here. So 4 absolute value 3x plus 2 plus 2 plus an 18. All right, so I want to first move the 2. 4 absolute value 3x plus 2 less than 16. Get rid of the 4. 3x plus 2 is less than 4. It's a less than, so it's an and again, okay? So we scoot it over a little bit, put a negative on this side, add another symbol, put this in the middle, the absolute value. What was in the absolute value in the middle, positive number over there, okay? And then isolate. And divide by the 3 to get the variable in the middle. So this is going to be a negative 2 and a 2/3. Oops. So this is x is greater than, turn this around, it's open to the x, negative 2, and x is less than 2/3. Okay, so negative 2 and 2/3. It is greater than negative 2 and less than 2/3. So these are also in parentheses. So negative 2, 2/3. Yep. Okay. Number 30 says, select all the following which represent a function. I'll do this one real quick. I have in mind the vertical line test. So if you can draw a vertical line through the line of the graph, that's considered the line of the graph, the blue one there, the squiggly one. And if you can draw a line straight down vertically and you hit the graph more than once, it is not a function. Okay, so if I'm representing one as y as a function of x, that's a function, because if you draw a straight line down anywhere on this line of the graph, you're only going to hit it once. So that is a function. Same with that one. Same with that one. And same with that one. This one, though, if you draw a straight line through, you hit it in more than one place. All these vertical lines hit it twice. So this one's not a function. All right, page number 31. Let's do a few of these. These are quick. These are radicals, right? A radicand is 121. That is a perfect square of 11. The square root of x squared comes out, that equals x. So our final answer for this one is 11x. Okay. 100 is a perfect square of 10. P squared, the square root of p squared is p. So 10p. Square root of 100 is 10. Square root of 28. This is what I do. I take the index, which is 2, and I divide it, and 2 into 28 goes 14 times. So that means all of the x's come out from under the radical, and there are 14 of them. So my final answer is 10 and 14. Okay. 25 is a 5. 22 divided by 2 is 11. I don't see an example. Let's say it was m to the 23 square root. 2 into there is 11 plus 1 extra. The way I do this is 11 comes out from underneath the radical and 1 stays in underneath the radical. Okay, so this one would be m to the 11th square root of m if it had said this one here. Okay. Let me keep going down here for a second. Square root of 343. Just start dividing it by things. It's not an even number. Think of your divisibility rules. It's not even, so 2's not going to, neither is a 4 or 6 or an 8, okay? So a 3 is not going to go in because that's the sum of all the digits. So 3 plus 4 is 7 plus 3 is 10, and 3 doesn't go into that. So try your 7, try your 13, and you'll find that that's a 7. And once you divide 343 by 7, you'll get the 49. Okay? So that's 7 and 7. 144 is a 12. That's definitely coming out. And look at the G's. Oops. There is 9. It's a square root. 2 into 9 is 8. So that's 4 of them come out and 1 stays in. So that's for just the G's. 4 of them came out and 1 stays in. Okay, that's how I do these. I hope that's helpful. That's a 2, so that's W squared. So the final answer for this one is 12G4, W2 square root of G. Okay. Let me do this one. I don't want to skip it. What did I just say about doing things out of order? Let's see. Business club wants to sell calendars to raise money. The profits selling calendars given by the following equation, which is out of order for a good quadratic. So let's do that with a of -1 and a b of 360 and a c of 0. All right, maximize profit. Maximize is code for use the vertex formula. X equals negative b over 2a. Vertex formula, negative b. So the b is 360, and the a is a negative 1. 180 calendars must be sold. And then once you find how many, you put that back in the formula so that they gave you, so you can figure out what the and it doesn't matter if you use this one or this one, it doesn't matter, just as long as you're substituting for x what you just found. Okay, so that's going to be 64 8 32 4 equals 32 4. Okay. All right, back down here. 19 divided by 2. 19 divided by 2 is 18, so that would be 9 times 2 is 18, so that leaves 1 remainder. So that means 9 come out and 1 stays in. That's how I do this. This is how many out, that's how many in. In under the radical, okay? All right, 18 has a perfect square of 9. What's left is a 2, and the b stay in there. 162 is an even number divided by 2. See what you have left. If you divide it by 2, you'll find out it's an 81 and a 2 left. 128 divided by 2, it's an even number. You get 64 2b. This is where it comes in handy knowing all your squares. So this is going to be 3 square root of 2b minus 9 square root of 2b plus 8 square root of 2b. So we're just taking 3 minus 9 plus 8 square root of 2b. So that's going to be 2 square root of 2b. Okay. Multiplying, outside times outside. Inside times inside, that's where I start these. Outside times outside, that's a 3 times 1 is 3, and a 2 times 14 is 28. 20 is a square root of 4 and a square root of 5. 28 is a square root of 4 and a square root of 7. So that's going to be 15 times 2. 15 times 2 is 30, square root of 5. And this one's going to be 2 times 3, which is 6, square root of 7. These are not like terms, you can't add them together. So don't add them together. So you can stop there, okay? This one, don't forget to write these twice. If something's in parentheses squared, you need to write them twice. It's not the same as each individual thing squared. It does not come out the same, okay? Times 1 is 1. Negative 3 squared 2. This one here. These are odd looking, but that's all we're doing here. Okay, now this one is a negative 3 times a negative 3 is a positive 9, and then a 2 times a 2 is a square root of 4. I have like terms here, so 1 minus, this is a negative 3 plus another negative 3. The square roots of 2's are like x's. You don't want to change them when you add, only when you're multiplying. So this is going to be 6 square root of 2, and then this is 9 times 2, which is 18. 18 plus 1 is 19 minus 6 square root of 2. Okay, and this one we're going to FOIL. That's what I did up here. I FOILed number 39. We're going to FOIL number 40. That's 64. This is 8's on the outside, so it's 8 times 1. And then the 6 comes along. Same with this one, only it's positive. and then inside times inside, but it's a negative times a positive, so it's a negative 36. These are like terms. When you add them together, you get a 0. So this is 64, and the square root of 36 is 6. Minus 6 is going to give you 58. And the last one is, remember, the denominator of the rational exponent. If you have a fractional exponent, the denominator is the index, so that goes there. Okay, this negative means it's underneath a 1, and the 3 means I have 3 of those. All right, so if you were processing them, the 4th root of 81 is a 3. Raised to the 3rd power would be 1 over 27. Okay.